Okay, so last time we stopped after learning about stoichiometry. We started and we know that 1 mole is equal to the molar mass of an element or the molar mass of a compound. And that's equal to Avogadro's number, which is 6.02 times 10 to the 23rd atoms, molecules, or formula units, depending on what it is. Molecules, if you're looking at whole compounds that are covalently bound, formula units, if you're looking at ionic compounds, and atoms, if you're looking for the individual atoms. Now, we also know that you can go from grams to moles by grams times 1 mole over the molar mass. That'll give us the number of moles. We also know that we can't go from grams straight to molecules. We have to go from grams to moles. Remember, we have to go through the doorway. This doorway is moles. And then we can go to our molecules or atoms or formula units. So that's a basic process. Now let's look, see if we remember from last lesson. I want you to pause, try these out, and then come back and see if you remember them. How many molecules are in 2.00 moles of water? Well, we know we have 2.00 moles of H2O. I look up here and I know I can go straight from moles to molecules, so I'm good. To do this, I use Avogadro's number. So we use 6.02 times 10 to the 23rd to do this. So I set it up. What do I want? I want molecules. What do I need to get rid of? I need to get rid of moles. I know there are 6.02 times 10 to the 23rd molecules for every 1 mole. This cancels out. If I put it into my calculator, 2 times 6.02 times 10 to the 24th gives me 1.20 times 10. Oh, it was 10 to the 23rd times 10 to the 24th molecules of water. So that is C. 2, how many atoms are in 3 moles of iron? We have our 3 moles of iron. We can go straight from moles to atoms, just like here. So times, I want atoms, so atoms go on top. Moles go on the bottom. 6.02 times 10 to the 23rd. So it's 3.00 times 6.02 times 10 to the 23rd equals 1.81 times 10 to the 24th atoms of iron. So that is B. Okay, let's look at 3. How many moles are in 1.24 times 10 to the 24th molecules? So we're going backwards here. So to do this one, we start with what we're given, 1.24 or 204 times 10 to the 24th molecules of carbon dioxide times, I want moles. So 1 mole will go on top. And I need to get rid of molecules. How many molecules are in 1 mole? 6.02, Avogadro's number, times 10 to the 23rd. Okay, now this is really important. When you use your calculator and you're dividing by an exponent, I'm going to bring this up. Make sure that when you divide, you have it in parentheses. Otherwise, you're going to get the wrong number. So here I have 1.204 times 10 to the 24th. We're saying times 1 divided by, because and this is a good calculator, it's desmos.com/scientific. So this way you can see what is happening on the screen. Because it's 6.02 times 10 to the 23rd, I need to make sure I have this in parentheses. You don't have to write it in parentheses, but you do need to make sure that you enter in parentheses on your calculator. 6.02 times 10 to the 23rd. Close those parentheses. And we click enter. And the answer is 2. So we come back. And our answer, we get 2.00 moles of CO2, which is right here. Okay. Let's continue. We're going to just be doing a lot of examples today where we're going in reverse, just like we did in that last example. So how many grams are there in 30 moles of water? Good look, we're given, what are we given? 30 moles of H2O. We want to know how many grams there are. So we're going to set it up. We can go from moles to grams, and we can go grams to moles. This is the same process that we were using before, only it's backwards. We still have to use the molar mass to do this. So to go from moles to grams, we want grams on top, grams of H2O, and we need moles of H2O. Well, how do I get my grams? Well, this is where I go to my periodic table. And I look in the periodic table, and I see that hydrogen has a mass of 1.01. Oxygen has a mass of 16.00. So I come back. Okay, so I come back here and I do my molar mass. I have 2 hydrogens, times 1.01 plus 1 oxygen, 16.00, and this gives me 18.02 grams per mole. My moles of H2O will cancel out because remember, my molar mass tells me how many grams are in 1 mole. So it's 30 times 18 divided by 1, and that gives me 54.06 grams of water. There we go. All right, let's look at this. Similar problem. How many grams are there in 45 moles of carbon dioxide? What are we starting with? Starting with 45 moles of CO2. What do we want? We want grams. We can go straight from moles to grams because if we know the molar mass, we know how many moles are in 1 gram, or how many grams are in 1 mole. I want grams of CO2, so that's going to go on top. My moles of CO2 need to cancel out. If I look at the periodic table, I know I have 1 carbon. The mass of 1 carbon is 12.01. Plus, I have 2 oxygens. The mass of 1 oxygen is 16.00. So my mass then is 44.01 grams. This is how many grams equals 1 mole of carbon dioxide. So in 1 mole of carbon dioxide, I have 44.01 grams. So 45 times 44.01 gives me 1,980 grams of CO2. There we go. Let's do another one. Are there in 5.43 times 10 to the 22nd molecules of water? Okay, we want to know the moles. What are we given? 5.43 times 10 to the 22nd molecules of water. Well, what do I know? If you're not sure what to do, start by thinking what you know. You know that, and it's okay if you write things down that you don't necessarily are going to use, but it helps to help gather your thoughts. So we know that 1 mole equals the molar mass that you get from the periodic table. 1 mole equals 6.02 times 10 to the 23rd molecules, atoms, or formula units. Okay, now that I have this all written, I look and I say, well, I have molecules. I want to go to moles. So I'm going to use this. So I want to go to moles. So moles is going to go on top. I want to get rid of molecules. So molecules is going to go on the bottom. 1 mole for every 6.02 times 10 to the 23rd. Now let's do this math. 5.43 times 10 to the 22nd times 1 divided by, in parentheses, 6.02 times 10 to the 23rd, close the parentheses, equals. So my answer is 0.090 moles of H2O. If you don't know how to do exponents on your calculator, please let me know. I want to be able to help you, and I'm fine meeting with you and walking you through the process because it's really important that you know this. We're going to take this one step farther. We can establish relationships using balance equations in what is known as stoichiometry. Here we have a balance equation. Nitrogen plus hydrogen, 3 hydrogen produces 2 ammonia. 2 ammonia. So in this above balance equation, we want to know how many moles of ammonia are produced from 1 mole of N2. So if I look, here I have 1 mole of N2 and if I start with 1 mole of N2, I can make 2 moles of NH3. It's like looking at a recipe and finding what you need and seeing how much you can make. My ingredients are 1 nitrogen and 3 hydrogen. That's what I need. If I have 1 nitrogen, I can make 2 ammonia. If I had 3 hydrogen, I can make 2 ammonia. That's all you're doing. You're making a ratio. If I have 1 mole of nitrogen, I can make 2 moles of ammonia. That's all we're doing. So now we look at this and we say, well, how many moles of H2 are needed to react with 1 mole of nitrogen? Well, my ingredient list, I need 3 moles of H2 for every 1 mole of N2. All I'm doing is looking at the balanced equation to come up with these numbers. This is our recipe. N2 plus 3H2 produces NH3. Now, I'm going to use that equation. I know how to change from grams to moles, and I know that if I have 1 mole of N2, I can make 2 moles of ammonia. Now, so we have this question. How many grams of hydrogen gas? So I'm going to write down grams of H2 because that's what we're looking for. Are required for 3.75 grams of nitrogen to react completely. So I look at this and I think, whoa, that's a lot. I have all the information here plus a periodic table, and we could do this. So I look and I say I have 3.75 grams. Well, here I know that I need 1 mole. Well, if I have 1 mole, then I can answer the question. I'll know how many moles of hydrogen I need, and then I can turn that into grams. So let's see how many moles of N2 this is. So say times 1 mole of N2 for every, oh, how do I find my grams in 1 mole for N2? This is where I use the periodic table and I find my molar mass. Here I have 2 of my nitrogens and I'm multiplying it by 14.0 because that's what the molar mass of nitrogen is if you look in the periodic table. So that gives me 28 grams of N2. So in 1 mole of N2, we have 28.00 grams of N2. So how many moles then do we have? We have 3.75 times 1 divided by 28. This gives me 0.134 moles of N2. Okay, now I have 0.134 moles of N2. I knew how to do that, but this says if I have 1 mole of N2, I can make, or I need 3 moles of H2 to react completely. I don't have that amount. This is like going to make a recipe that needs 4 eggs, but you only have 1. How do you figure out how to scale everything down? That's what we're doing here. We don't have enough for a complete recipe. We only have this amount right there. So let's look at this. If I have 0.134 moles of N2, according to my recipe, I need 1 mole for every 3 moles of H2. Well, I know I need to cancel out my moles of N2. And I know I want to find my moles of H2. Because if I can find my moles of H2, I can go to grams of H2. So according to the recipe, if I have 1 mole of N2, I need 3 moles of H2. My moles of N2 will cancel out, and that'll tell me how many moles of H2 I have. So let's see, 0.134 times 3. This gives me 0.402 moles of H2. I'm on my way. Now I can turn moles of H2 into grams of H2 because I know to calculate the grams, I'm going to use my molar mass from the periodic table. I have 2 hydrogens times 1.01. That gives me 2.02 grams and 1 mole. So I could say 0.402 moles of H2 times, I need grams of H2, and I need to get rid of moles of H2. I know for every 2.02 grams of H2, I have 1 mole of H2. So 0.402 times 2.02 divided by 1. If I have 3.75 grams of nitrogen, I only need 0.812 grams of hydrogen. I know that's a lot. Let me know if you need help. Here's a nicer version of it so that you could see step by step. I didn't show you how to get the molar mass like here. I didn't show you how to get the molar mass because I know that you can do that. But the rest of it is written out a lot neater than what I could write. Okay, this is the last little bit. I want you to try to practice this do these questions and then come back and check your responses. How many moles of H2 are needed to react with 1 mole of oxygen to form water? So we have this balanced equation right here. All we have to do with this one is look and see. We have 1 mole of water right here. How many moles of H2? We only need 2 moles of H2. So this one, you didn't have to do any math. You just had to look and find the number. 2. How many grams of carbon dioxide are produced when 2.00 moles of C2H6 combust completely? And you have your balance equation right here. All right. How many grams of CO2? So we're looking for grams of CO2 for this one. We're starting with 2.00 moles of C2H6. All right, so we want to go from moles of C2H6 to grams of CO2. We can't do that straight. We have to go first from moles of CO2 or moles of C2H6. I'm just building a road map here. Then we can go to moles using the balance equation of CO2. And then using the periodic table, we can go to the grams of CO2. Okay, so I want to go to moles of CO2. So I look at my balance equation. I got to cancel out my moles of C2H6. How many moles of C2H6 do I have? I have 2. If I have 2 moles of C2H6, how many moles of carbon dioxide can I make? I can make 4. So that'll cancel out. So it's 2 times 4 divided by 2. And this will give me 4 moles of CO2. Now that I have my moles of CO2, I can go to grams. And look, this was so kind. It gave us the molar mass already. So I don't even have to calculate the molar mass. I say I have 4 moles of CO2 times, I want to go to grams of CO2. I want to get rid of moles CO2. My moles of CO2 cancel. I have 44.0 grams for 1 mole. So this is 4 times 44.0 divided by 1 gives us 176 grams of CO2. There we go. Okay, 3. Given the equation right here, nitrogen plus 3 hydrogen produces 2 ammonia. How many moles of ammonia are produced from 6 moles of H2? Okay, I'm starting with 6 moles of H2. What do I want to go into? I want to go to moles of ammonia. What do I need to get rid of to do that? I need to get rid of my moles of O2 or of H2. Looking at the balance equation, if I have 3 moles of H2, I can make 2 moles. That's 2. 3 moles of H2. If I have 3 moles of H2, I can make 2 moles of ammonia. Moles of H2 cancel. 6 times 2 divided by 3 gives me 4 moles of NH3. And that is it. Okay, the example we did on the previous page, that's as hard as it's going to get. If you have questions, let me know. Practice, 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 practice. You'll do great. Okay, here is a nice little chart. You have it in your notes. And it's a chart of how to do the calculations. You can go from moles of A to moles of B using your balanced equation here. So with this, you'd use your balanced equation. You have to make sure the equation is balanced. We'll do molarity later. So don't worry about this until next week. Number of particles using Avogadro's number, which is 6.02 times 10 to the 23rd. So you can go from moles to atoms, molecules, or formula unit. That's why it says number of particles, because it's any of those. Again, you can go from moles to number of particles using Avogadro's number. Use a molar mass from the periodic table to find the mass. If you have questions, please reach out. Do your practice problems. Those will help more than you realize. And we're done for the day.